Welcome back to section 2. We shall be looking at more examples on variation. Question 1. If D varies directly as S, remember in section 1 we dealt with this sign called sign of proportionality, and when D is 20, S is 5. Find A, the formula that connects D and S together. We have spoken about formula that connects. It could be law, it could be relationship that connects them together. Then B, find D when S is 10. Let's get started. D varies directly as S. That means the first thing to do is to change this sign of proportionality, and that becomes D equals, introduce a constant. We have this. So when D is 20, we have K times S. So your S is 5. What do you do here now? You divide both sides by 5. Very good. Divide by 5. Divide by 5. Such that K equals 5 here 1, 5 here 4. So K equals to 4. Now, first question says, find the formula that connects them together. We will always get the formula that connects them from the second step, which is this place, and that becomes D equals the value of our K constant. We got 4 and we have S. So this is the formula that connects D and S together. Now question B says, find D. We're looking for D when S equals to 10. And going back to the law, we have D equals 4 times 10. Therefore, D equals 40. If there is any question, pause the video and go back. Now look at the second question. The question says, if P varies inversely, so you have to watch out for the word inversely. As the square, we have as the square of Q. We're very careful to differentiate between square and square roots. Now look at the question. P varies inversely. So let's turn it to mathematical way of writing variation. P varies inversely from our first section is 1 over, in this case we have square of Q. What do you think that would be? Q squared. The next step is to change this thing to the sign of proportionality. You put an equals to sign, then we have a constant, then you write what you have back again. So our aim now is to calculate the law that connects them together of the formula or the relationship. From the question, P equals 8. K times 1 is K. So my Q is 4. So we have 4 squared. So in that case, we are going to be having K will now be equals to 8 times 4 times 4. So what do you think 8 times 4 will be? So that is easy. We have 16 times 8, or you say 8 times 4. 8 times 4 is 32. Then 32 times 4. 4 times 2, that gives us 8. 4 times 3, that gives us 12, and that is 128. So our K equals 128. Therefore, the law that connects them together, remember, is usually taken from the second step, and the law that connects them is this place, and that becomes P equals K over K squared, and the K is 128 all over Q squared. So this is the law that connects them together, and that is not what we are required to calculate. We are required to calculate find Q when P is 32. So what do? We go back to the law. P is 32. You put the value of P as 32. P is 32 equals 128 over Q squared. And what do you think this will be? If you cross multiply very well, you'll be having 32Q squared equals 128. And if you do that very well, what do you think we are going to get there? Divide both sides by 32 by 32. So we are going to be having Q squared will now be equals to 128 divided by 32. Let's cut. 2 here 16, 2 here 6, and 2 in 8 is what? 4. Very good. So there is no need of using calculator. You can also do everything, so that Q will now be plus or minus square root of 64 over 16. Don't need to divide that, just continue, and that becomes plus or minus, what's the root of 64? That would be 8, and what's the root of 16? That is 4. So our answer becomes plus or minus 4 here 1, 4 here 2, and that is plus or minus 2. See you in section 3.